Welcome to the notes on the Pythagorean Theorem. Okay, so the Pythagorean Theorem, one of the most important formulas in geometry. Again, this only works when we're dealing with right triangles, all right? Remember, right triangles measures 90 degrees. All right, you know it's a right triangle because there's that right triangle symbol. Okay, so keep that in mind. So the Pythagorean Theorem, what is it? All right, here it is. It is the leg squared plus the leg squared, and it always equals the hypotenuse squared. I'm just going to write HYP. Okay, so right triangle, three sides. How do you know which side's the leg? How do you know which side is the hypotenuse? Well, the trick I like to remember is the letter L forms a 90-degree angle. So the letter L is also in the word leg. So the legs are the two sides that form the 90-degree angle. So this is a leg, and this is a leg. And then the hypotenuse, all right, that's the side that's across from the 90-degree angle, all right? It's the non-leg side. Two sides of the leg. It's the only side that's not a leg. Longest side, whatever you want to call it, that is the hypotenuse. So there is your formula right here. Remember, it's always equal to the hypotenuse squared. Okay, a lot of times people want to set it equal to the unknown. It's always equal to the hypotenuse squared. So let's take a look at some examples. All right, so it says find the missing side for each of the following right triangles. So here's our missing side. I'm going to call it X. Now notice, that is one of the legs. Okay, so when we set up the formula, we're going to say 6 squared, because that's a leg, plus x squared. Notice I'm not setting it equal to x. It's always set equal to the hypotenuse. And once you have it set up, it becomes an algebra problem. Very simple. So 36 squared is 36 plus x squared equals 100. We're going to subtract the 36 from each side, subtract the 36. So x squared equals 64. Now, I don't want x squared, I want x. So how do I get rid of that squared? I take the square root. Well, so the square root of 64 then is 8. So x equals 8. Okay? Now, once you have it set up, and that's the majority, let's do another one here. Which side? Okay, this side, this time our unknown is the hypotenuse. So I think that's even a little easier. So we just go leg squared. Again, these are the legs right here forming the 90. So 12 squared plus 5 squared equals x squared. All right, 12 squared is 144 plus 15 or 5 squared is 25 equals x squared. So that's 169 equals x squared. Take the square root. Again, it's 169 square root. So x equals 13. That's how you use Pythagorean theorem. All right. Now, they might ask, is each triangle a right triangle? Basically, if the Pythagorean theorem works, then yes. If the Pythagorean theorem does not work, then no. So just set it up. Here's our legs, 3 and 4. So 3 squared plus 4 squared. Does that equal our hypotenuse of 5 squared? So 3 squared plus 4 squared, that's 9 plus 16. Does that equal 25? 25 equals 25. It works, so this is yes. All right, every set of numbers won't always work, all right? You can't use any 3 numbers you want for a right triangle. It has to follow Pythagorean theorem. Let's take a look at this example. 5 squared plus 10 squared. Does that equal 12 squared? Again, always set equal to the hypotenuse. Well, 5 squared is 25 plus 10 squared is 100. Does that equal 144? 125 does not equal 144. So this is a no. It is not a right triangle. So notice that's how these problems work. There's the Pythagorean theorem. One skill that you're going to need today is simplifying radicals. Okay, to simplify radicals, you have to factor, all right? You've got to factor them using a perfect square. And I'm going to write that out so you guys can see it and remember it. Okay, perfect squares. What are perfect squares? Well, it's when you take the square root, it's a whole number. So square root of 1 you're not really going to use, but like what is the square root of 4? All right, that is a perfect square because it's 2. All right, what is the square root of 9? It's a perfect square because it's 3. All right, the square root of 16 is 4. Square root of 25. I'm going to list out a bunch so you guys can see them all. Square root of 36. For 6, square root of 49. For 7, square root of 64. And the square root of 81 for 9. And obviously you guys didn't know the square root of 10, or 10 squared is 100. So those are your perfect squares. Now, how do we simplify a radical? Let's take a look at an example. So when you simplify it, you have to use one factor. And again, a factor is a divisor. So give me two numbers that basically multiply into 32, or can be divided by 32, square root of 32. Well, I know I can use and we want to try to use the greatest perfect square. Well, I know in this case that 16, square root of 16 times the square root of 2, times the square root of 2 is square root of 32. Now, again, this equals the same. One of these has to be a perfect square. Give me two factors, one's perfect square. Well, square root of 16, that is just 4. It's not root 4, it is 4. The square root of 2 doesn't simplify, so root 32 breaks down to 4 root 2. This one, a little bit bigger, okay? Sometimes they're big numbers. You might not know what the greatest perfect square is. We'll try a smaller number, okay? So I'm going to try square root of 4. If you see an even number, usually square root of 4 goes in there. So I'm going to say, hey, the square root of 4 times the square root of, well, 4 goes into 252 times, and it's actually 63 times. Now notice I still put the radicals above. It's not 4 times 63, it's root 4 times root 63 equals square root of 252. Now, square root of 4, all right, that is a perfect square. That becomes a 2. Now, root 63, though, you always got to check. Can we break this down further using perfect squares? We can, all right? Root 9 times root 7. Root 9 is a perfect square. That becomes a 3 times our root 7. Now, once it's outside, this is all multiplication. So this 2 is being multiplied by this 3. So it's really 2 times 3 times root 7. So this is actually 6 root 7 would be our final answer. Since that's a 6 on the outside, I know that I could have used root 36 times root 7, and that would have gave me 252. So there you have it, Pythagorean theorem and simplifying radicals, two skills you will need in this section.